But that's tomorrow, right? Yeah. Anybody have any difficulties?
It's telling me that my free trial expires.
Your free trial? Oh, yeah. Does everybody say that?
Yeah.
That's not good.
What
What is that about? Let me see here.
I just down $2 to check in. Andrew, got it in A. And you said
Looks like most people are starting to get taken care of, so that's fine. I will try to figure out why that is. This. Now, okay. So, I'm going to go ahead and just take this. Side. Okay, so let's go ahead and take care of this first of all now. So now everyone's hopefully logging into there. And I will look into why it's saying you have 13 days left. I'm not quite sure what that's about, other than things have been screwed up all year long. So we can just add that to our list of things getting screwed up. So yesterday, your job was to, not yesterday, Tuesday when you left, your job was to finish filling this thing out, the ordered pairs on it. Okay? We had already put the degrees on here. We had already put the radians on here. And I had given you how many of the ordered pairs? 5. Where all the axes intersect the circle. And then I had given you this very first one here as well. Okay? And we had calculated or found those coordinates by using special right triangle rules for 30, 60, 90s. Okay? So real quick, let's put our radians on here. So just everybody turn yours over. If you have it, just turn it over. And I'm going to see how we're doing on this. I'm just going to ask somebody to give me what I'll go around it. I'm not going to just point to one, but I'm going to go around it, and I'm just going to ask people to give me what these are in radians. Because, as I said, tomorrow there is going to be a timed quiz on this. Okay? All right. Let's get this thing. Huh?
how much time?
Maximum of 4 minutes. Max of 4 minutes. Okay. Okay, so here we go. So we know that this starts at 0 and ends at 2 pi. Okay, so let's start going here. So, who wants to give me this very first one here? Owen.
Isn't it like 5 or 6?
Pi over 6. Boom. Dylan, you got this one? Pi over 4. Noah. Pi over 3.
3.
Anybody? Pi over 2. Okay, good. Here we go. We're going to keep going.
2 pi over 2.
Thank you. 2 pi over 3.
3 pi over 4.
3 pi over 4.
5 pi over 6.
5 pi over 6. And of course, this is at
5.
5. Okay. It didn't take us long to do that. Okay? It doesn't take us long at all to do that. Let's keep going here. Down here now we're at 7 pi over 6. 5 pi over 4. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. And 11 pi over 6. Okay? So we want to be able to do that. We want to know where those are. Okay, we want to know where those are. Now we did the ordered pairs. So the easy ordered pairs, of course, were on the axes. And since it's the unit circle, that means the radius is 1. So we know that this is at 1, 0. This is at 0, 1. This is at negative 1, 0. And this is at 0, negative 1. Now let's fill in the one I gave you yesterday. The other one I gave you this one right here. And this was at radical 3 over 2, 1/2. Okay, now, before we go any further, let's talk about the next one, pi over 4. I said that one you have to find using special right triangles, and then once you're done with that, you don't have to use special right triangles on any of the other ones. When I do this next one right here, if I create the right triangle here, there it is. Here's x, here's y. This is pi over 4, which we know is how many degrees? 45. This is a 45, 45, 90 then. And again, this is 1. The hypotenuse is always 1 on these when I draw right triangles. So if I wanted to use special right triangle rules, I have to use the rules for 45, 45, 90s. So what was that? Well, in the 45, 45, 90s, this was the rule you guys had. That was it. Okay? So I have given you this. I have told you that x times radical 2 is equal to 1. That's what you know right now. This equals 1. How do I solve that for x? I would divide by radical 2. Okay, now, you get this. They're really and truly, that is completely correct. I will tell you, almost every book, every test, anything you ever see, this particular one will be written in a rationalized form. Okay? This one here, I would expect you, and because you're going to memorize it anyways, is going to be rationalized. All right? To do that, all I have to do is multiply the top and bottom by radical 2. In doing that, I get that x is equal to radical 2 over, in the bottom I get the whole number 2. And that's not always, that's going to be both x and y. The ordered pairs there are the same. So for this one right here, it's going to be a radical 2 over 2, radical 2 over 2. Okay? Now, that I said is all you needed to do, special right triangles, get those, and the rest is all about can you take things and analyze and flip and change signs. How do I go about getting this one right here? Ryan, what do you think? Yeah, it's just going to be these two flipped around. It's still going to be a 30, 60, 90, but it's just going to be in flipped form. So it's going to be at 1/2 radical 3 over 2. All right. Now we're going to head into quadrant 2. What's going to happen in quadrant 2? So all I have to do is go straight across and make the x value negative and keep the y value the same. So like this particular one, I'm going to go purple again with this. This, that's not new purple, that's new black, would be at negative 1/2 radical 3 over 2. This would be at negative radical 2 over 2, radical 2 over 2. And this would be at negative radical 3 over 2, 1/2. Done. That's it. Because all I did was reflected it across the y-axis, which means the x value sign changes. That's it. Now I'm coming down here. Now I can take these and do what? Keep the x and change the y values and make them negatives, because I'm going to reflect these across the x-axis. So this is going to be at negative radical 3 over 2, negative 1/2. Negative radical 2 over 2, negative radical 2 over 2. Negative 1/2, negative radical 3 over 2. Done. Now I'm into quadrant 4. When I go to quadrant 4, I can either take these and move them over, or take these and move them. That's my choice. I don't care. It doesn't matter. Okay, so here we go. What's this one going to be at? 1/2 negative radical 3 over 2. Radical 2 over 2, negative radical 2 over 2. Radical 3 over 2, negative 1/2. Boom. There it is. We have filled it out. Okay? We have filled it out. All right. Any questions about the unit circle and how we got anything on there? We're okay with all of that? And we're still, how are we feeling about the radian stuff out there? Do we have questions about where those came from? Like, how we got any of these, or why is this 2 pi? I mean, or could somebody tell me, when we're talking about angles being measured in radians, what is that dealing with? Measuring in degrees is just nothing more than a fraction of 360. It's how many out of 360 possible rotations, how many did you move? That's not what radians is, though. What is radians? Radians compares what?
The radius to how much the circle is in the arc.
Yeah, it's the arc length that's been cut off divided by the radius. Because we said 1 radian is when arc length is equal to the radius. So if I wanted, on the unit circle, if I wanted to draw an angle of 1 radian, what would the length of my arc length be? On this unit circle, if I wanted to draw an angle that is 1 radian, what arc length would I need to cut off? That'd be the whole circle, bud. 1. I would need it to be the same as the what? Radius. Okay? I'd need it to be the same as the radius. So here, let's talk about that and make sure. So here we are. This is just a circle. Okay? We always start right here. This is 0. Okay? Let's say that this is r. It's the radius. Let's say I start going like this, and I stop right here. That's where I stop at. And I have an angle right here, theta. And I tell you that this is 1/2 r. How many radians is this? It's a 1/2 a radian. It's 1/2 of a radian then. Let's do another one. I start here. So this was this one. Okay, I'm going to go ahead and do this. And let's say I go to about, I don't know, right about there. Oh my goodness. What happened? Get out of there. Hello? Get out of there. Let's do that again. Boom, there it is. Beautiful. Okay, there it is. This arc length is 2r. How many radians is it? 2 radians. Let's change this now. Let's go ahead and say that, what do I have on the next page? I don't have another circle like that. Thought I did. That's okay. We'll do one more here. We'll change this now and make this an actual value. Let's say that this radius is 50. Doesn't matter what unit it is. Feet, inches, does not matter. And I'm going to go ahead and cut off an arc length here in purple. So I'm going to go. Okay, so here is my angle. This is angle alpha. And I tell you that this arc length right here is, oh, I don't know. What do we got here? What do I think that is? $170. And I want to know how many radians it is. What would I do?
170 divided by 50.
It would just be alpha is 170 over 50, which is 17 over 5. And if you divided that out, this is a nice decimal, it'd be what? 3 point what? 3.4. Now, real quick, let's talk about this. We know from here to here is how much in radians? What is it in radians if I go from here to here? Pi, which is about what? 3 point. Does that make sense then? Yeah. Okay, so that's the idea. This idea of radians, it's the idea of comparing how much of the circle circumference have we covered, the arc length compared to the radius. Okay. Now, this is something kind of, we didn't really state it yesterday this way, but when we're talking about angles on position of a circle, one of the things we need to make sure of is that we are always going to measure our angles with respect to the horizontal. That's where we always start, not the vertical. So we don't start up here. Like, can anybody tell me, is there some circle that does have 0 at the top? Is there any circle in real world that has a 0 up at the top? A clock? It might, because sometimes 12 is considered what? Midnight, it's 0, 100, right? That's 0. So that could be a clock, potentially, yeah. Is there anything else? What? A compass. A compass, this is north, right? And that's 0. And guess what's really weird about a compass? Which way does the needle go? It can go either way, but when it goes this way, guess what kind of angle it is? Does anybody know what this is on compass? Well, how many degrees? This is at 90 degrees. This way is positive on a compass. On a compass, that's 0, that's positive. So there's a reason that we have to say, because really and truly in life, if you go out and you see something, usually this is where 0 is. But for math's sake, we don't do that. We always start on the positive x-axis. So we talk about it, we call it like the 3 o'clock position. That's what it would be on the clock. It's the 3 o'clock position. It's the what? Positive, I've said it before, it's the positive x-axis, okay? So we talked about that yesterday. I just didn't put it in those terms. Now, let's kind of do a quick review of yesterday, just to see where we are on what we did. Okay? Will, what's going on, bud? Are you looking at Mrs. Howdy? Okay, so from yesterday, this would be review. Tell me what type of an angle that is I just drew. It's acute, that's true. Anything else you can tell me it is? Nothing else? Yeah, it's positive. How do I know it's positive? Because of the direction of the rotation. It tells me it's going this direction. Okay? How does this angle right here, if it lets me do it, how does it differ than this one? This one's in standard position. Okay? Their measurements would be the same, but we call this one in standard position. So that's something we want to remember as well. Okay, great. Here we go. What can you tell me about that angle right there, the green one? It's negative. What else can you tell me? It's standard position. What else can you tell me? It is obtuse. Well, obtuse actually is between like pi over 2 and pi. So it's outside of that even. There is something else you can tell me about it. It's what? It's coterminal to the blue angle. Those two angles are coterminal, which means what? Same start. They start and stop at the exact same locations. What do we call those locations? We say they have the same. What do we call this where the angle starts? It is 0, but this is called the what of the angle? The initial side. This is called the terminal. So we say they have the same initial and terminal side. Okay? We also know that that's not the only coterminal angle to those. How do you get another coterminal angle? Do another full rotation. If I went ahead and did this right here, those two are, the blue and the red, are coterminal. What if I told you that this angle right here, we're just going to call this one theta. This angle theta right here, I'm going to tell you that it is, let's see here, about 0.98 radians. Okay? Could you tell me the red one's measurement in radians? Hold it. So the red one right here, we'll just go ahead and call that one beta. It's what?
0.9 plus the full root, which is 2 pi.
It's 0.98 plus 2 pi. Because that's what a full revolution is. It's 2 pi radians. Okay? Do these two angles, do angle theta and beta, do they have the same coordinates for their terminal side? Yeah, they're going to have the exact same location for the terminal side. They share the terminal side, so it has to be at the exact same ordered pair of coordinates, okay? Can somebody give me the green one, by the way, now?
2 pi minus 1.98.
Okay, so we're going to go ahead and call this one here alpha. So alpha, if I go 2 pi minus 0.98, what kind of an angle is that going to give me? I can do it this way, but what's that going to give me? A positive, right? It's going to give me a positive. So I have to do something to this. What do you mean flip it? If I did this, what if I just did this? It's the negative of 2 pi minus 0.98. Would that work? Now, if I do this, let's see what this is really telling me then. Distribute the negative through. So what is alpha really equal? 0.98 minus 2 pi. And that will just give me my negative number and I'll be done. Okay? You can do it either way. It doesn't matter how you do it. So really all you have to do is either take your initial angle and either add 2 pi or subtract 2 pi to get a coterminal angle. You add or subtract multiples of 2 pi to get a coterminal angle. Add or subtract multiples of 2 pi. So if I went ahead and did 0.98 minus 4 pi, that would be another coterminal angle. If I did 0.98 plus 4 pi, that would be another coterminal angle. Okay. So those are things that we need to know. We kind of already talked about it. We know that going this direction is positive and going this direction is negative. Is there anything, so we've just kind of reviewed yesterday right now is what we've done. Is there anything from yesterday that you would like to ask about? Maybe anything I said yesterday, or maybe I've even said it today, and you want to like get some clarification on it. Anything at all? I don't think so, Mr. Smatter. All right. All right. Let's keep going here then. So, wait a second. What is? Oh, something was. I must have covered it up. Or I deleted it by accident. That's okay. So, before I do this page, I'm going to go ahead and kick an extra page in here. This is review from before spring break and the first day back. Okay. Let's say that this is, oh, I don't know, 5. I want to find x, and I'll call this one. Well, let's not do that. Let's call. This is janky today. We'll call these B and D. I like this better. There we go. And I'm going to tell you this angle right here is, that's not 72. There's no way it's 72 degrees. Man, this is like slow today. Find B and D for me real fast, would you? This is review. This is leading into today. Find B and D for me. La 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 la. Who wants to tell me how, not what, how to find D? wants to tell me how to find? People don't have their hand up. Hey! Cosine of 27. D over 5. Beautiful. So what's D going to be? What am I going to do to find D? Boom, love it. Okay, and I'm just going to stop there because hopefully you can all type that in and get an answer. Okay, great. Okay, the blue one then. Yep.
Sine of 27 equals b over 5. And then e equals 5 times 27, or sine of 27.
Great. Okay. All right. Fantastic. So when you come back in a second, because at 21 is our break, we're now going to see why am I doing all of this stuff kind of like, I'm going to show you what's going to happen here. We're going to bring this kind of together. So you get an idea of why I'm doing all these kind of things like right triangle, trig, and the unit circle. Why is this? How's it going to come together? You'll find out when we come back.
Anyway,
Text me. I might be up. Might be up for it. I might be. I don't know what's going on. Like it just goes. And then it's start tying this stuff together. The circle and the trig, figure out what's going on here. Okay, so here I have another unit circle. This is a unit circle. Okay. And what I want to do is I'm just going to draw an angle in standard position. Doesn't matter where it is. I'm just going to draw this angle right here. I can't assume that that's at pi over 3. It's just up in that region, but I don't know where it is. Okay. All right, beautiful. Now, and this, of course, is my angle. So, yesterday, when we did the special right triangles, we went ahead and we found x and y by using special right triangles on a unit circle. How would I find those exact same coordinates if it's not a special right triangle? Okay? So remember, this is a unit circle. And if it's a unit circle, of course, this length here is what? 1. Now, what should I do? Well, what did I do yesterday to find them? I did draw a what? I drew a triangle, a right triangle. Because x and y, they're always going to be perpendicular to each other. So I'm going to do that here. I'm going to draw a right triangle. Here. Boom. There it is. Beautiful, isn't it? It's a gorgeous right triangle. This is x. This is y. Okay? There's x, there's y. Now, think about what we just did before break. How would I find x? How would I find y? Well, if I want to find x, what would I say? It's where compared to the theta, the angle. Adjacent. I've given you the hypotenuse. That tells me then that the cosine of theta is equal to x over 1, which simply means that x is equal to the cosine of theta. X is equal to the cosine of theta. This right here is at cosine theta, comma. Now we'll do the same thing for y. Well, let's see. Y is where? Opposite. Oh, so that would be the sine of theta equals y over 1, which means y is equal to the Now, hold it a second. This is craziness. Am I saying to you that if I went ahead and put an angle right here, which is at pi over 6, and I wanted to get those ordered pairs, instead of using special right triangles, I could do the cosine of pi over 6 and the sine of pi over 6? Well, we better just see if that's a lie. Mr. Schneider could be lying to you. Let's see if he is. I hope he's not. He is. He's been lying for the past 27 years. Book roll 1. Here we go. La 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 la. Start. Come on. All right, here we go. Now, the first thing is I got to make sure that I'm in radians, okay? I need to make sure that I'm in radians because that's the angle I gave you. Here we go. Sine of pi over 6. Look what it says it is. 0.5, which is what? That's what we said it was. And if I do cosine of it, the cosine of pi over 6, cosine of pi divided by 6, I get this. Now, it doesn't say turn it into a fraction, but guess what? Right below it, if I were to do the square root of 3 divided by 2, guess what I get? Oh, that's not supposed to be in the denominator like that. Back up. The square root of 3. Okay, really? Why won't you type it? I'm not a big Desmos person myself. This is so much easier to do on my calculator. Divided by 2. Oh, there it is. It's the same. Well, that's kind of nice. That's it. As a matter of fact, that's really nice. That I can find the coordinates on that circle very easily by just taking the cosine of the rotational angle theta and the sine of it. Now, I do have a question for you. If this angle right here is pi over 6, I'm going to draw that angle there. So this one here, there's pi over 6, this one here. Who can give me the measure of this angle here? This one. What's that one going to be?
Pi over 6 minus 2 pi.
Pi over 6 minus 2 pi. By the way, if this angle, think about the unit circle. If I went this way, what was this angle right here? 11 pi over 6. So guess what happens if I go this way and stop? That's negative 11 pi over 6. Now guess what? That means if I want, I literally could take the what? Cosine of negative 11 pi over 6, and it better work as well. I'm going to try it. I just need to see if this is true or not. Here we go. So we're going to get rid of this nonsense. Let's just clear this one out. Okay? So I'm going to do the cosine of negative 11 pi divided by 6. Oh my goodness! It gave me the same answer. And that means if I do the sine of negative 11 pi over 6, I'll get the same answer of 1/2 again. Okay, that's kind of nice. As a matter of fact, the cosine and sine of any coterminal angle to pi over 6 is going to be the exact same location. Now, you might still be saying, okay, Mr. Snyder, so what? What does that really mean? Like, how often do we work with just a circle of radius 1, right? I mean, how many circles out there that you've seen have a radius that's exactly 1 unit? Probably not very many. Probably not very many, okay? But right here on the unit circle, okay, on the unit circle, we know that this, this is delayed. X and X. If X is the rotation. If you don't like that, you can make it theta instead. Cosine theta, sine theta. Again, that's only for the unit circle. Yeah, Krista. 2 pi. And that's how you get a coterminal angle. Add or subtract multiples of 2 pi. You want to sit up here today, Krista, so you can see better?
I have glasses that I just got. That's why.
Okay, you're fine. I just was asking you. Okay. All right. So what happens if this is not a unit circle? What happens if all of a sudden I have a circle that's got a radius that's not 1? Like, all of a sudden I have this, and I've got a circle, and I say to you, okay, I'm going to draw another angle here. Here we go. And this time, the radius is just r. I don't know what it is. Maybe it's 1, maybe it's 5, maybe it's 12. It will never be negative because a radius can't be negative because it's a length. R is there. Here's theta, and I want to find x and y for this. Okay, let's think about this. Right triangle. Here's x, here's y. How do I find x? The cosine of theta equals x over r, which means x is equal to r times the cosine of theta. Everybody look for a second. Look back to the problems we did right here. Guess what this 5 is? It's the what? It's the radius. Boop, boop. Okay, so there's that. This is for any circle now. It doesn't matter if it's a unit circle or not. R could be 1. If R is 1, it's just cosine theta. If R is 2, it's 2 cosine theta. If the radius is 12, then the x value is going to be at 12 cosine theta. And then, of course, the y value is going to be that the sine of theta equals y over r, which means y is equal to r sine theta. Okay, so for any circle, of radius r, the coordinates at terminal side are cosine theta, r sine theta. Now I'm going to tell you something right now. I just walked down Mr. Miller's room to talk to him real fast between classes. His Calc 2 class down there right now, they're dealing with what is called polar coordinates. And in polar coordinates, they need that. Okay? So this is going to be something that will show up. This r cosine theta, r sine theta. It will show up. Okay. Does anyone want to ask anything at this point in time? All we've done now is found out, hey, if I want to find the coordinates of the terminal side, I can use cosine and sine. That's what we're finding out now. So that means we don't have to have just special angles that we would use. Like yesterday, all we could do were the familiar angles that were at the 30s, the 60s, the 45s and stuff, because we could use special right triangles to get them. Now we can actually find a location at any angle theta, and we can find its location. Oh, okay. Perfect. Love it. Great. Wonderful. Here we go. Are you ready? I'm going to give you this one. I want you to try it. I'm just going to give you the following. So let's make it a different color. Okay. So I'm going to tell you that theta here is 5.42. And I'm going to tell you that the radius on this thing is what? Oh, how about 6. Find the coordinates down here. Give me x and y. Yeah. It's right there. You are a terrible thing. I hate you. Really? So finding the x value, what am I going to type into my calculator here? me, what would I type into my calculator or Desmos?
Cosine or
6 times the cosine of 5.42. And to get the y value, it would be 6 times the sine of 5.42. Now, who in here is using a graphing, like a TI? Are you in radians for sure?
Yeah.
Okay. Are you for sure in radians, Dylan? Hit mode, you are. You're not. There you are. Okay. Anybody else using, are you in radians? You changed it? Okay. Anybody else using the graphing? Hit mode. You already in it? Okay, good. I just wanted to make sure. So let's go ahead and get this then. All right? So now we've got this right here, this location. What do we get for the x coordinate then? Somebody want to give me the x coordinate? A little louder. 3.90. Okay? And then the y value. Who's got it? Don't let me do the splits. Hurry, help me. Negative 4.56. Love it. Great. Okay. Did you have to use 5.42 to do this? No. If somebody wanted, if they wanted, could they have found this negative coterminal angle and used it instead? Sure they could have. That'd have been their choice. Okay? I don't know why you would do that, but you could. All right. So I'm curious about something here. I thought I had one more circle. Let me go ahead and duplicate this page that I'm on. Clone page. Clown it. There we go. Good. Okay, so this is the one I want. Good. Let's just get rid of all this stuff on here. I have a question for you. Can anybody tell me where on the circle is the sign going to be positive? For what types of angles is sine positive? What's that? Just quadrant 2? And 1, yeah. Here and here, that is where sine's going to be positive. How do I know that? Because the y values are what? Positive. Okay? Where is the cosine going to be positive at? 1 and 4. Here and here are where the cosines are positive. So both of them are positive in quadrant 1. Only sine in quadrant 2, only cosine in quadrant 4, which means what happens in quadrant 3? They're both negative. Okay? They're both negative. Okay. All right, I'm feeling pretty good right now. I think you're kind of ready to see why in the world we are doing this still, because all I've done is now made a connection between right triangle trigonometry and these angles in the rotations and trying to find the coordinates. That's all I've done so far is made a connection between those two. How would we ever possibly use this? Let me show you. Here we go. All right. Anybody been to London? Okay. It's okay. You don't have to be in London. So anyways, here we go. The London Eye Ferris wheel. That's that like monstrosity, huge, huge Ferris wheel in London. They celebrated the millennium. British Airways funded construction of the London Eye. At that time, the world's largest Ferris wheel. The wheel is located on the south bank of the River Thames in London, England, measuring 450 feet in diameter. That's pretty tall, okay? Carries up to 800 passengers in 32 capsules. It turns continuously, completing a single rotation once every 30 minutes. This is slow enough for people to hop on and off while it turns, so it never stops. When it gets down here, it's moving so slow, people can get off and still get on, and it's not a problem. So they never stop it. So look what this says. Ferris wheel height as a function of time. Now I know when I'm looking at this, height would be a what coordinate? A y coordinate. Okay. I like this already. Because I'm looking at like this spot right here, this height, this y value is somehow related to how far has this capsule rotated in the ride. All right? Okay, good. Here we go. So it says, suppose you hop on the Ferris wheel at time t equals 0 and ride it for 2 full turns. It's a long time, right? That's an hour. Let f of t be your height above the ground, measured in feet as a function of t, the number of minutes you have been riding, and we can figure out some values of f of t. Okay, all right. So I'm going to ask you guys to help me find some heights. You guys, you can help me with that, right? So what do we need to know right now? Now, in general, we're going to consider this height to be what? 0. We know that it's not exactly at 0, because if it was at 0, that would mean that things would be hitting the ground. But the pods that you sit in, they literally come down within inches of the ground, so you can just step right into them. So they basically, for all intents and purposes of 450 feet, we consider it 0. So we're not going to worry about that, okay? Okay, here we go. So, boom. Since we can measure position on the Ferris wheel using angles, we see that the height above the ground is a function of the angle position on the wheel. Great. We can rewrite our table giving heights as a function of angle instead of time. That's what we're going to do. So here you go. Your height above ground y is a function of the angle turned in the wheel. Okay, now, notice it says theta, and it's just blank. We're going to do this in radians. Are you with me? Now, remember what we said you were starting at. We're starting, and if I go back to the picture, you're starting down here, and look which direction it's rotating. Okay? So if I'm going to start here, do I want to call this angle 0? No. What am I going to call this angle that I'm starting at? Because we know when I get to this point here, when I get to here, this is now going to be what? 0. What is this going to be then? Let's do it in radians. Careful. 3 pi over 2. Okay, I could do that if I put 3 pi over 2, but then this won't be 0. This would be 2 pi, wouldn't it? Think backwards. Go backwards. Negative pi over 2. Thank you very much. That's what we're going to start at. If that's 0, anything before it has to be a negative. Okay? So this is at negative pi over 2. That's where we're going to start our ride at. Okay? That's where we're going to start at. All right. Here we go. So negative pi over 2. And then I think I'm going to go ahead and count by, how many do I have here? That would be this. Boom, 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 boom. I got enough spaces here. I can do quite a bit. Let's do negative pi over 2. Let's do negative pi over 4. Let's do 0. Let's do pi over 4. Let's do pi over 2. 3 pi over 4. Pi. 5 pi over 4. 3 pi over 2. Are you guys okay with me? Is this one rotation around? Is that a full rotation? If I start at negative pi over 2 and I end at 3 pi over 2, is that one full rotation? What do you think? Yes, it is. Okay, so here's a full rotation, all right? So I want to know how many feet above the ground we are. Now we said we're going to say basically at the bottom it's where? 0. Great. It's at 0. Okay, negative pi over 4. How am I going to do this? What would I type into my calculator? What would I type into the calculator? Guys, I'm right here. And that radius is what, by the way? 225, because the diameter is 450. So the radius is 225. So how would I find that location? It would be what? 225 times the sine of negative pi over 4. Literally, this would be 225 times the sine of negative pi over 4. That's what I would do. We just got done saying that's how you find the y coordinates. Would somebody please give me your height? Just round to the nearest 10. Negative 159.1. Negative 159.1. Oh boy. Is that what it is? Is that what you guys get? It should be a positive, shouldn't it? Because the sign in quadrant 4 should be what? A negative, and a negative. Oh, wait, what about this? This is going to be a negative times positive. It's a negative. How am I going to deal with this? Because I know this would mean I'm where? Underground. What in the world? How am I going to handle to make sure that I don't get back negative 159.1? Any thoughts? No one has any thoughts on that? How I could. No? Well, let me ask you this. Let's do this one and tell me what you get. And we'll come back to this. We'll come back to this in a second. Do this one right now. Tell me where you are. Yeah, it's saying you're where? 0. We know that's not 0. As a matter of fact, we actually know what this height is right here, don't we? What is that height going to be? 225. What is going on here? Why is this happening to us? Does anybody know why?
Because we're still splitting up the circle like it's quadrant 1, 2, 3, 4, which it is, but it's giving us negative numbers.
Yeah.
So we really just need to add 225.
Yes, I want everyone to think about this. Here's the origin. Usually below the origin is what kind of a number? A negative. But this case, it's not. What happened to the origin? Instead of being at ground level 0, so that the Ferris wheel went underground, which would be kind of fun actually, it's been moved up how far? 225. So since the origin has been moved up to 25, I have to add 225 to all of my values. If I do it using sine, cosine, and stuff, or by using sine. I didn't have to do it here. Oh, sorry. I did not have to do it here because I already know that's at 0. I said that in my head. So if I do this one here, now where do I end up at? 65.9. Like that a lot better. And then this is going to be, guess where? 225. Now guess where this one's going to be at? You think about these two numbers. What am I going to do? Somebody said it. Add them together. Add them together. Think back to here. If this is at 45, this distance here, is it going to be the same as this distance here? Be careful. Is it going to be the same? This distance and this distance would be the same, wouldn't they? If this is 60, whatever you said it was, and from here to here is 225, is that also 60 some? It's not, is it? Okay, well, let's just go ahead and do this the other way. Let's just go ahead and type it into our calculators. Let's just type in sine of pi over 4, and then should say 225 sine pi over 4, and then add 225 to it and tell me where you're at. So for this one here, I'm going to write down what we just did. We're going to do 225 times the sine of pi over 4. And then we're going to add to that 225. Oh, that's not a plus sign there. It should be a times sign. Somebody have this? 384.1. Beautiful. Pi over 2. Pi over 2, anybody? 450, that's at the top now. Now I do not have to do any more calculations because now we're doing all reflections. Right? This height would be the same as that height, because now I'm coming back down. So this is going to be at 384.1. Pi is going to be at 220. 5 pi over 4 is going to be at 65.9. And 3 pi over 2 is going to be back at 0. Okay? All right. So I'm not going to do these bottom ones here. I'm going to I want to graph this. We're going to create a little graph for this. Are you okay with that? Are you okay? We're going to create a graph. So I'm going to come over here, and I'm actually going to put, let me do this. Oh, shapes, and I want a square, a rectangle. Where's my, hello, open up. I don't like new software. I really wish sometimes that I had my old computer. All right. And we'll do this, and we'll do this. And this. Yeah, that's it. Okay. All right. So, come on. Don't get stuck there. All right. Beautiful. So I'm going to draw a graph of this. Now, can anybody tell me what the inputs, what were our inputs on this? What were our inputs and outputs? What were the inputs? What were the domain values? When you plugged it in, guys, your output was always the what? The height. Outputs, when we graph things, outputs are like what values? Y values, right? So the inputs, the angles were like the X values, right? And the outputs were like the Y. So now here's the thing. This graph is not a circle, but I want you to just look at what happens here. So watch this. This is pretty cool. All right. So, boom, boom. All right. So here we go. This is the height. This is the height. So up here, this would be 450. Down here, of course, would be at 0. This would be at 225. Okay? And in between here, I could put those other heights if I wanted to. So 65.9, that's what I'm going to need. So let's just say this is 125, about right here maybe. Here's 65.9. And then right about here is the 384.1. All right. Across here, I'm going to put those angles. All right? I'm just going to put them there. So I'm going to let this be negative pi over 2. And then I'm going to put negative pi over 4. And then I'm going to put 0. And then I'm going to put pi over 4. And then I'm going to put pi over 2. And I'm going to put 3 pi over 4. Pi. I'm going to put my other ones here. We've got, what, 5 pi over 4. And my last one is 3 pi over 2. All right. This first point, where's it at? Right down here. The next one's right here. Right? 25. Where's this one at? Here. Where's this one at? Here. Then what happens? It repeats and it comes back down like this. And then the next one is, that's right about there, I should say. And then this one is right about here. And then this one's right about here. And then at 3 pi over 2, it's back down to here. And this graph goes like this. Okay? That's what that graph looks like. Now, what would happen, do you think, if I did another round? Would these values change? No. How would I get my second part of this graph? What would it look like compared to the first part? What's that? It would just be another one of those, right? I would just take this and duplicate it, and it would happen again, correct? That's what would happen. Okay. Yeah, it would just go back up, and it would continue looking like that over and over and over again. Now, we're getting closer and closer to the whole thing here, but I want everyone to just watch something here real fast. Let me, oh my gosh, where did it go? You guys are just along for the ride right now. And that is the wrong calculator. So I need the graphing one here. Start. All right, and I want to make sure I'm in radians. Radians, and I'm going to go from negative pi over 2 to 3 pi over 2. My y-axis is going to go from 0 to 450. So I'm going to go ahead and I want to write a function to model this ride. What your heights look like. Okay? I want to model it. Okay, so when I do this, I'm going to go ahead. This cursor, where in the... Oh man, this cursor is... I have to restart my computer because something's just not right. What happened to that? Oh no, it's gone. Ah! You guys ever have those moments where things just aren't the way you want them to be? You guys don't ever have that happen, do you? I didn't think so. Okay. Hopefully I'll get it in there. I'm trying to open this other thing up real fast, and it's causing me great consternation. Consternation, great word. What's it mean? No, it doesn't mean no clue. Okay. What is going on with my computer? Nothing is working. I got the spinning wheel of death on my computer screen right now. All right, well, guess what? We may not get to this. If we have to, I might start class this. Tonight, here's what you need to do tonight. Tonight, you need to look over what we've talked about. And the big thing about it is not the Ferris wheel, okay? It's, do you understand the relationship between the coordinates of the terminal side and the angle using cosine and sine? Make sure that you also are knowing the unit circle because you're taking that timed quiz tomorrow on that so that you can finish it in 4 minutes. You have to put down all of the radian measurements and all the coordinates. You do not have to do degrees on them. It's the radians and the coordinates. And remember, I want radical 2 over 2. I do not want 1 over radical 2. Okay? So study that stuff up tonight, guys. Tomorrow we'll keep going. I got to say, no problem.
No, that's quite a problem.